So again, an ideal gas is a hypothetical gas or a perfect model of gas used to simplify calculations. Usually, such gas have no forces and they have negligible volume. That is no volume, and that is not true. Right? So this is the formula for an ideal gas equation. It is PV is equal to nRT. Right? So let's look at this question that we have here. The question is, calculate the number of moles present in a certain mass of gas occupying 6.5 dm3 at 380 m and 15 degrees Celsius, given that R, which is the universal gas constant, is equal to 0.082 atm dm3 per Kelvin per mole. So, the first thing I would want to do here is to fish out the parameters in this question. So the question again is, calculate the number of moles present in a certain mass of gas. Calculate the number of what? Of moles. So what we're looking for is the number of moles, which is n. It is unknown. That is what we're looking for. Present in a certain mass of gas occupying 6.5 dm3. So that tells us about volume, right? So the volume of the gas is 6.5 dm3 at 3 atm. That's the pressure. So the pressure is equal to what? 3 atm and 15 degrees Celsius. That tells us about temperature. So the temperature is equal to what? 15 degrees Celsius. And in gas laws, we don't work with Celsius, we work with Kelvin. So converting into Kelvin, that would be 273 plus what? Plus 15. Plus this 15. So that will be equal to 273 plus 15 will give me 288 what? Kelvin. So the temperature 15 degrees Celsius is what? 288 Kelvin. And then we are given our R, which is the universal gas constant, to be what? 0.082 atm dm3 per Kelvin per what? Per mole. So having fished out the parameters, the next thing I would do is to write out the formula for an ideal gas equation. So an ideal gas equation is PV is equal to nR what? nRT. PV is equal to nRT. This is the equation for an ideal gas, right? PV is equal to nRT. PV is equal to nRT. So that's what we have here. The PV is equal to what? nRT. So what we're looking for is what? The number of moles, which is n. So to make this n the subject of the formula, I will divide both sides of the equation by the coefficient of n, which is RT. The coefficient of n is whatever that is attached to n, and that is what? RT. So this is divided by RT, divided by what? RT. So this RT will cancel out this RT so that this n can stand alone. So that will be PV over RT is equal to what? N. Right? So in other words, my n is equal to PV over what? RT. So this expression and this expression are the same. Right? So the next thing I would want to do is to put in my values. Right? It is to put in my values. So I have from here that my n is equal to PV over what? RT. So this will be equal to, my P is what? My P is 3 atm, right? So that will be 3 times my V, which is the volume, is what? 6.5 dm3. So that will be 6.5 divided by my R, which is the universal gas constant, is 0.082, right? 0.082 times my temperature T is what? 15 degrees Celsius, and I converted it to Kelvin and it gave me 288 Kelvin. So that will be times what? 288, right? So my n will be equal to 3 times 6.5 will give me 19.5 over 0.082 times 288 will give me 23.616. So you can punch that in your calculator, right? So 19.5 divided by 23.616 will give me 0.616. 0.83, right? So this is my answer to this question, 0.83 mole, because this is what n is for, what is the number of moles. So my n is equal to what? 0.83 mole. This is my answer to this question, right? So the important thing that you should know here is for you to know the equation for an ideal gas. The equation for an ideal gas is PV is equal to nRT. You must always remember that. And know that your P is pressure, which is measured in atm. Your V is volume, which is measured in dmq. Your N is mole, is the number of mole. Your R in the formula is the universal gas constant, and the value is 0.082 atm dmq per Kelvin per mole. Then your T in the formula is temperature, and the temperature should be in what? In Kelvin, right? So it's actually a very simple and straightforward question, right? So in the next video, we're going to look at another example, and this is the example we'll be looking at.